simplifies problems a lot, and I really like to do that. And the other one is graphical, which I really love when you have pictures. Okay, you ready?
Careful.
Okay. Oh, here it is. It's sitting up here. Whoops. Okay, get out a blank. You're not handing it in, but get out a clean piece of notebook paper. Like start fresh. Okay, the word resultant. What do you know the resultant to be? Okay, the sum of the forces, right? Sum of the forces, right? Mathematics. Don't write that down. Just write down result. So it's the sum of the forces. But why really do you want to know the sum of the forces? Physically. You want to know how much it's going to move in a certain direction. But the sum of the forces, is that the only thing that'll tell you how it's going to move? What else do you have to do? Some of the moments, right? If you want to know what the resultant of something is, if I take this and I throw this to Cameron, you want to know what the resultant is, right? And the resultant is the motion. Is it going to be linear? Is it translational? Is it going to rotate, right? And the direction. So the resultant is a vector, and it does have a magnitude and a direction, but it's really, the definition is, it's really the sum of the forces, and it's the sum of the moments. And this gives you the translational motion. This thing still isn't off. Oh, it doesn't matter. I can. And this is rotational motion. That's what a resultant is from now on. When you came into this class, if I asked you for the definition of a resultant, you would have told me it was the sum of the forces. And maybe even now. But now we moved into moments. So no longer is the resultant only representing forces. The resultant is representing the forces and the moment. So if I spin and move this way, what is my resultant? My resultant is some value of the moment, right, and the direction, and some value of this motion. Everybody get it? So if a problem says, what is the resultant? Do you just sum up the forces? No, you got to sum up the forces and sum up the moment. So that's the first thing we need to know. Okay, next. I have a bracket. I have a 100-pound force here. Notice I like pounds, huh? And I have a 20-pound force here, and this is point A, and this is 3 feet, and this is, I'll use different numbers. So 4 feet, this is 2 feet, this is 2, I don't know. This is 5 feet. And I ask you, what is the resultant? So what do you want to tell me? Malcolm?
First thing we'll start right is in inches rather than pounds.
Thank you. Okay. So I want to know what the resultant is. You got to give me one answer or 2 answers? 2 answers. So let's give me the first answer.
So forces
Sum of the forces equal,
equals -105.
you know what, let's do it all in our head. Represented in vector form. What is it?
-100.
-100I
-50.
J pounds. How did I represent it here?
Vector form.
Vector form. What else could I do? I can do or magnitude. And what's the magnitude? What's the resultant force? 100 squared plus 50 squared under the radical. Can somebody do the math on that? $111.8 pounds. And then I can find the direction angles if I want, but we're not going to do it now. Okay, what else? My question said, what is the resultant? You just found the resultant force. What else do I need? The resultant moment. And do I need to tell you the point you're going to find the moment about? Why? Because there are no couples. So let's do A. So it's 30 times 4 negative, 100 times 3 positive, 20 times 11 negative. And what does it come out to be? Negative 1200 plus 300, that's 180, 180 plus 180. $400? Did it come out to be 400? Oh no, I added positives and negatives. No, it's not. Okay, what is it? I have to do it.
-40?
Negative 40?
Yeah.
Somebody else got that, huh? Yeah. But no. Okay, so initially, you were given this problem. And we're going to take that problem. Here's point A. And we have 40 foot-pounds, and the resultant is 100 . So let's see, we have a force, and it's going in the negative x and the negative y, right? I didn't put my axes over here, I didn't do that. And how long is this beam? This beam is 6'11". If I took that force and of negative 100, so give me your, show me with your arm which direction this force is going in. Negative 100I minus 50J, it's going down here, right? If I took it and I put the force here, and what is that force? It's 111, and the direction is 2 to 1, right? And I put a moment on it. Of 40 inch-pound. Inch-pound? Foot-pound. So let's look at what's going on. First, you're given 3 forces at certain distances from point A, and right now we're trying to find what is the resultant at point A. We learned that the net effect of these 3 forces in these directions has a resultant force of 111.8 pounds in this direction, and it creates a spin. Show me the spin with your right hand. Is it like this? No, it's like that. let's say I wanted to make an equivalent system. I wanted to apply equivalent force moment system that's equal to this. These three forces, if we look at the net effect on A, does this force with this, what is this thing called, remember? A concentrated moment. If I apply a force in this direction of 111.8 and put in a screwdriver and turn it 40 foot-pounds, or a torque wrench is probably better, torque wrench, and would this system have the same net effect, the same resultant as this?
Yes.
Yeah,
Yes.
the same. If I learned that with this bracket, here's the bracket. I didn't draw the whole bracket in here. 6, 5. So I have this bracket with these three forces. Tell me, if you make believe you're holding up that bracket. You're holding up the bracket, what's happened to it? It's going down and it's spinning like this. Right? You have the bracket in your hand. I have the bracket in my hand, and it's being pulled down here, and at the same time it's spinning. Right? It's being pulled down here, but at the same time it's spinning, being pulled down here. What do you
Just pull out a bracket.
Okay, is that the same as this? Here, it's being pulled down and it's spinning at the same time. Right? Same. Which one do you like better? A or B?
B.
A or B?
B.
A or B?
A.
B. Why B? It's easier. Okay, so this is called an equivalent force moment system. What did you do? You calculated the force, you calculated the moment, and you stuck them right on the picture at the point in question. And that's point A. All right? But there's another equivalent system. What are you doing? 4 minutes, huh? Margie, you're keeping me honest here? Okay, don't watch that too closely, then you're not paying attention here. Okay, 6 feet, 5 feet. What's that bracket? 3. What is this? NTS.
Not to scale.
Not to scale, right? Because I certainly am not doing a good job drawing it to scale. Oh wait, is that 6 if that's 5? So we know that the resultant force is going in this direction, right? So we want the resultant force going in that direction. But I don't want to use a torque wrench. I just want to apply this force at one point here. So I have to apply this, and this is point A, right? Okay, using the right hand rule. Is this force out here at 111.8 pounds? Or is it to the left, or is it to the right of A? And how are you figuring it out?
Right, it has 1 foot.
Okay, how do you figure it out? Put your fingers in the direction of the force. If it's here, and my palm goes towards A, what kind of moment would I get? Positive or negative? Positive. If the force is here, fingers go in the direction of force, palm goes towards the point, would I get a negative? What kind of moment do we have? So it's not here, right? Let's leave this and just say, no, it's not there. So it's got to be here. But I don't know where it is. I don't know how far it is. But can I figure it out? Can I figure out what this perpendicular distance is?
Yes.
What is D perpendicular? How can I calculate it?
Magnitude of moment divided by the force.
Magnitude divided by the force, because remember, we already know, you guys, we already know the moment is equal to the absolute value of the force times the absolute value of the perpendicular distance. So if I'm trying to find the perpendicular distance, it's going to be the absolute value of the moment divided by the force. So what's the moment? What was the moment?
40.
40. And what's the force? 11.8. And what's the perpendicular distance? Do the math. This is a small moment. Say it again.
0.35.
0.357, so let's just say 6 feet. So actually, it's pretty close, isn't it? Yeah? So where do I have to put this force? That looks, if I am drawing somewhat to scale, right? If this is 6 feet, and this is, boy, it's got to be like somewhere here. I'll exaggerate it. The resultant force is 118 pounds. And this perpendicular distance right here, does everybody see that? This is the perpendicular distance, and what is it? 0.36 feet. So, ooh, good. Oh no, it's over. Okay, is this an equivalent system?
Yeah.
I take the bracket, and I apply a force right here that pushes the bracket down and causes it. Sorry, this is the point I'm finding the moment about. I gotta hold this. This is hard. Force goes down, it's pushing it down, and at the same time it's spinning. Equivalent systems. What is this equivalent system? It's called an equivalent, and this is my name for it, equivalent force location system. You get the difference, right? The difference? The force moment system is a force and a moment at that point. A force location is applying only the force at a certain location and creates the same moment. Okay, good luck on physics 4C. Now you're ready for the video. The video is going to work through 3 problems.